Especially in settings where robots assist with activities of daily living, trust is a critical factor in human-robot interaction and cooperation, but it can be strongly impacted by failures. A human's willingness to trust is linked with their belief that a robot can behave appropriately without intervention. In this work, we conduct a human study to investigate how trust in assistive robots is impacted when those robots make mistakes. We conducted a 19-participant trial across 2 different populations, where we evaluated the responses of younger and older participants when 2 different assistive robots made errors. We hypothesized that observable errors would cause a decrease in the level of trust reported by human participants, and that this decrease would be more pronounced among individuals in the older age group. We define a simple bathing task where a robot cleans shaving cream off a participant's leg in a single pass. This task was conducted only with individuals in the younger population. 3 types of intentional error are included, with severity ranging from a minor reduction in performance to complete task failure, requiring researchers to manually reset the robot. We also define a feeding task, where the robot attempts to feed the participant hard and soft foods. This task was conducted with individuals in both populations. There are 4 intentional errors included in this task, which again range in their level of severity, from a shallow scoop to the robot physically dislodging the bowl plate and flinging food at participants. We evaluated these simple bathing and feeding interfaces with 2 age groups, a population recruited at Carnegie Mellon with median age 26, and a population of older adults from a local independent living facility with a median age 83. Each participant experienced 9 trials of each task in which they participated. Trials were divided into groups of 3, with manufactured errors being randomly introduced only after the first group of trials was completed. We administered a demographic questionnaire at the beginning of the study to assess each participant's level of familiarity with robotic systems. After each set of 3 trials, participants filled out a set of questions adapted from the Human-Computer Trust Scale in order to measure their level of trust towards the robots. We also conducted an analysis of their questionnaire responses in order to investigate the impact of errors on trust, as well as the potential difference in response demonstrated by an older age group. Finally, we conducted a thematic analysis of open-ended questions which were administered after participants had completed all trials. This figure depicts the questionnaire responses observed after each group of 3 trials for younger individuals engaging with the bathing task. As expected, immediately after the introduction of error, we observe a statistically significant decrease in scoring for all the question categories between the first and second sets of trials. However, after the third set of trials, we observe a rebound effect in the first 3 question categories, with the responses increasing to a level not significantly different from the initial values. With younger participants in the feeding task, we again observed a statistically significant difference after error was introduced. However, with this task, the same rebound effect was not observed. In contrast to the distinct pattern observed with younger participants, we did not observe statistically significant differences in responses given by the older population across any set of trials in the feeding task. This result appears to contradict our initial hypothesis that older adults would display a more pronounced response to these types of errors. We directly compare the change in trust responses between the younger and older populations via a 2-sample t-test. This test also did not indicate any significant differences between the 2 groups. We additionally conducted a thematic analysis on open-ended responses to survey questions which were administered to both age groups. A notable conclusion from this analysis was that younger adults were significantly more likely to make judgments about the robot, which cited specific performance-based factors observed during the study, rather than non-performance-based factors, such as concern for the lack of human interaction when a robot is introduced. Overall, we observed that task type and age did impact how resilient trust in a robot was to errors. However, the lack of observable differences between responses given by older adults ran contrary to our initial assumption that this group would receive the errors more harshly. Additionally, it appears a user's level of familiarity with robots may be correlated with how likely they are to judge the robot based on its performance, a factor that should be taken into account when designing assistive robots.